Hello and good morning, Year 5s. It is Tuesday, it's our maths, and we're going to continue looking at volume, which, remember, is lots of our other skills just being applied to another area. So essentially, if we can do our long multiplication, we're pretty much nailing volume. Let's have a quick look at our do now, and then we'll get cracking. So, there we go. So, first ones. Is the y-axis horizontal or vertical? Well, it's the vertical one. It's the one that's going down, up and down. How do you find the area of a rectangle? We should know this. So we multiply, don't we? We multiply the length times the width. So we do length times width equals area. Or 7 times 3. What is an obtuse angle? Well, this doesn't mean draw one. It means, tell me what it is. So an obtuse angle is an angle between 91 and 179 degrees. Because remember, 90 is a right angle and 180 is a straight line. So any of these possibilities are obtuse, but 90 is not obtuse. If you've put it's 90 to 180, which a lot of people do, then that's not right, okay? Roman numerals, 79. Right, so break it down. Right, how to make 70? Well, the biggest numeral I can have is 50, 60, 70. And then how to make 9? Well, that's 1 before 10. Boom. What's this one here? L, V, I. So the L is 50. V, 5, 6, 7. 57. And then this one here, 487. Again, let's do 400 first. So 4 is always like the 1 before, isn't it? Or 10 before. So it's 100 before 500. 80 is going to be 50, 60, 70, 80, and then 7, 5, 6, 7. Ooh, bit of a long one there. It's a good one. I like, love Roman numerals. Right, fractions. 4 and 6 tenths is how many tenths? Well, we've got 4 whole things, which means we've got 4 things that are 10 out of 10. So 4 tens are 40, and we've got 6 extras, 46 tenths. 22 thirds as a mixed fraction. Well, we know it's going to be thirds. We're not doing anything with the denominator. So how many whole? Remember, 3 threes would be 1 whole. So we're counting up in threes here. So how many threes go in 22? Well, 7 is 21, isn't it? 7 times 3 is 21. So we can get to 7, and then we just need an extra one to get to 22. It's all your division and multiplication skills, which is why I say so much about making sure our times tables are solid, because that will take you so long if you don't know your times tables. If you don't see, right, 3 is 22, well that's 3 times 7. If you don't see that quick, it's gonna be a task that is longer than it needs to be. 8 sevenths and 4 sevenths, and I want this as a mixed and an improper fraction. So as an improper fraction, quite simple, 8 and 4, 12. Or can you see that? It is how many sevens fit into 12? Well, you've got 1, 8, 9, 10, 11, 12, and 5 sevenths. There you go. Lovely jubbly. Right. On to tripod's a bit stiff today. So, on to today's task. Now, it looks very similar to yesterday, and it is, but it's just that little bit step up. You've got to use a little bit more Year 5 and, 4 and wherever, prior knowledge, and apply them to these. Because I know almost everybody will be like, volume, right, yeah, I get it. That is not what's going to happen for the Year 5 and Year 6 and beyond. It's not just going to be, here's a volume question, and it's, oh yeah, 7 times 3 times 2. They will want, you need to be able to show that you understand what volume is and apply all the math skills to it. So, we'll go through these. The first one, we've got 20, 12 and 15. So I'm looking at those, and well, 20 is lovely to use. Half it is 10, and we know how to times by 10. So times by 20 is just doubling it, isn't it? So I'm going to choose 15. So I know straight away that 20 times 15 is going to be, well, 10 times 15 is going to be 150. So 20 times 15 is going to be 300. So I'm going to do that straight away. Okay? Because 20 times 15 equals 300. Because 10 times 15 equals 150. So I've put the 0 on the end, and then I've doubled 15 to 30. It's these sorts of things we've got to spot quickly for year 5 and 6 now, rather than spending a couple of minutes doing a long multiplication doing 20 times 15. I've now got 12 left, so now I've got 300 multiplied by 12. So I've done my, well, this is the height, isn't it? The 12 that's left is the height. So we can do this. We can either times it by 10. Well, let's work this one out. Let's work this one out as we would do. So 300 multiplied by 12. Although we should know, actually, you should be screaming at the camera going, actually, no, Mr. Cooper, 12 times 3 and bung 2 zeros on the end. 12, 24, 36. Bung 2 zeros on the end. Don't want to do that at all. So that first one actually doesn't require any written calculation at all. Okay? You've got to start thinking like that. Don't just see volume, write and write a long multiplication out. Look for some number patterns. So that was number 1, 3,600 centimetres squared. And the next one, we've got that one there, which is 40 by 33 times 3. Well, again, I can do 33 times 3 in my head because it's just 3 times 3 twice. 33, you double it, you triple in the 3, 3, 6, 9. So I've got 99. Okay, so the second one, that was number 1. The second one, let me just I've got, just so I can see it myself here. Oops, that didn't go right. So you've got 40, 33, and 3. Well, 33 times, I'm going to do another one here where I don't think I'm going to need to write anything down. 33 times 3 is 99. And then we've got to times 99 by 40. Now hang on a minute, if we got any sort of multiple of 10, we do our 0 trick, don't we? So 99 times 4, well, let's work that one out instead, because it's going to be quicker, isn't it? So 99 times 4, because we're not going to need to do 0 here. 9 times 4, well, that's 36. 9 times 4 is 36. Add 3 more is 39. And don't forget the 0 on the end. So, number 2 is 3,960 centimetres cubed. Got to be looking for shortcuts where we can. Right. The next one. You might be looking at this thinking, Mr. Cooper, I've only got one piece of information. Ha ha ha, no. Don't forget, we've discussed this when looking at properties of shapes. If you've got a line on the sides of a shape, it means that they are equal. Okay? 2 lines mean parallel. So, on here, obviously, you could look at it and go, well, I think that's a square. But if those lines weren't there, then it wasn't. But because they are all equal, you know that it's 8 all the way around. So you know that every direction is 8. So it's 8 times 8 times 8. It's essentially 8 cubed. Okay? Now, some of us have been remembering our cube numbers. But, to be fair, 8 cubed, don't potentially remember what it is. You should know 8 squared. So you should know that 8 times 8 is 64. But, let's find out what 8 cubed is. 8 times 4, 8, 16, 24, 32. And 8 times 6, well, 8 times 5 is 40. So 8 times 6 is going to be 48. Add 3, 51. So you've got 512 centimetres cubed. Lovely jubbly. So I've done the first 3 now, and I've not had to do anything mathematically that I wouldn't have done before lockdown at the moment. And that goes for you guys, as in, you know, these calculations are things we would have been doing, like, beginning of year 5. It's just the concept of volume. The next one. Okay, right, okay, we've got these lines again here. So that's telling me that all these ones are the same. And it's actually given me the surface area, the area that the face is taking up. Now, you should be looking at that thinking, right, I've got a number that's going length and width that's got to make 49. Well, there's only one number that when you times by itself makes 49. And you should be screaming at me that it is 7. 7 times 7 is 49. So you now know that it's 7 by 7 by 6. Okay? So your calculation is 7 by 7 by 6. So number 4. Well, you already know that 7 times 7 is 49. You've been given that bit. So 49 times 6. 9 times 6 is 54. 6 times 4 is 24. Add 5 is going to be 29. So 294 centimetres cubed. Excellent. Right, on to the bottom line. Now, it might be that this bottom line, you look at and think, ooh, don't know about this. That's fine. The bottom line is like another step up. If you manage to do those first 4, hats off to you. Fantastic, well done. If you manage to, on that first line, know what you wanted to do, but couldn't quite figure out the last bit, that's also fine. All right? But as long as we're approaching these, knowing an idea of what you need to do. This one here, we've clearly got a cuboid, we've got a rectangular face, so it means all these faces are rectangles. So we know that's 3 by 7, so that's going to be 7 as well, isn't it? It's going to be 3 by 7 by 7. Hang on, I've just done 7 times 7, so y is going to be 7. So 7 times 7 is 49. We've just got to times that by 3. Oh, back to the piece of paper. Back to a very quick multiplication. 9, 18, 27. 12, 14. 147 centimetres cubed. And that's number 5. Oh, sorry, there isn't a number 5, that's number 6. Number 7, you might be thinking, what on earth is this? Now, number 7 is actually, whenever you see a question like this, sometimes the easiest questions, they just look the hardest. You've not got any numbers. You've got letters representing all of these. All you need to show is that you understand the properties of a rectangle here. So all you need to show is you understand that these two are going to be the same and that one's different. So you could make a really simple calculation here. You could put like the lowest numbers possible. The shortest one can be 1. So t can be 1, and those guys can be 2 or 3 or 4. Let's not make it too hard for ourselves. So this one is just, this is more of this is a property of shapes question rather than volume, because you've just got to show that you understand what possible lengths these sides could be. So I'm going to go 1, and I'm going to go 3 and 3. So 3 times 3 is 9, times 1 is 9, because it's just one row of 9. Okay? So obviously there's not a strict answer to that one, but you've got to make sure your numbers that you input are correct. Now, the last two, I'm gonna go to that one last. I'm going to go to this one first. This one here, first of all, looks really strange and complicated, but it's just like any other question, angles, fractions, whatever. All the information is there for you. So on this one, they've not given you the full measurements. They've given you the measurement of one of these well, they'd be cuboids here, wouldn't they? Well, no, they should be cubes, but they're cuboids. So they've given you the measurement of just one of these, and you know it is 2 by 5 by 2, because the 2's down here. So you know that down here is 3 of them, so 5, 10, 15. I'm going to write that down. You know what, I might even draw the shape. And you know what, sometimes drawing the shape really helps. So I know that this is 15 because that's into 3. I know that we've got 2, 4, 6 at the bottom and 2, 4, 6 along. So it's 6 along the bottom and 6 stretched out to the back. Well, I'm going to be honest, I know what 6 times 6 is straight away. There's no point doing 15 times 6. Well, let's do the ones we know. 6 times 6 is 36. So I've got 36 times 15. 6 times 5 is 30. 5 times 3 is 15. 16, 17, 18. Done with the 5. 0 in there. 6 times 1 is 6. 3 times 1 is 3. Add them together. Boom. 8 and 6 is 14. 3, 4, 5. There you go. 540 centimetres cubed. Now, the last one can get very confusing very quickly, which is why there is a question like it. You'll notice you've got very simple digits within those numbers, a 5, a 2 and a 2. What's awkward is the actual measurement. It's 0.05 centimetres, 0.2 centimetres. Even if you tried to convert those into millimetres, you'd still be left with kind of like a ½ millimetre, which can be quite odd to work with. There's another trick though. Now don't forget, when we multiply long multiplication and there's a decimal, I've been telling you to ignore the decimal and put it in at the end with however many places are after the decimal in the question. So why don't we just do 5 times 2 times 2 and then put the decimal in the right place. Basically, today's lesson is all about how to cheat in maths. So, we've got 0.05, we've got 0.2, and we've got 0.2. So, 5 times 2, we know is 10. Okay. Times 2 is 20. Lovely. But remember, we've got all these decimals. So I'm going to write 20. But we've got to put a decimal place in. And we need to put 1, 2, 3, 4. Okay. So we're going to go 1, 2, 3, 4. So it's 0.002. Now that might have blown your mind a little bit. I had to check because I didn't believe the answer, and that is correct. So, well, we don't need that 0 because there's no, it's not doing any sort of place holding. So, the answer is 0.002 centimetres cubed. Do not worry if you didn't get that one. That was a very quick cheat at the end. Okay? So, the challenge at the end, I'm going to let you explore. And I will just talk very quickly through it. It's a bit of a number pattern. So the first one here, first one's very easy because you've got 2 of the 3 numbers. 3 times 2 is 6. You need a number to get to 18. Ugh. The next one's not quite as easy because you've only got 1 number, but you do know what you need to get to your answer. So think about, my little clue to you is, what can you times by to get to 60 that's in the 4s? And I'm going to leave that there because it is actually a little bit simpler than you might think, okay? But good luck with that, and well done. Fantastic. And like I said, a lot of those were actually spotting quick ways of doing your questions. Please do not panic if you looked at these ones here. That's fine. But I'll be honest, these ones here, I think most of us have got enough mathematical common sense, if that makes sense, to approach them. So well done. Fantastic, guys.